Okay, so here let's get into some deep solution architecture when you want to have a data engineering pipeline that's going to be real time. So let's take an example. We have producers and they can produce into a Kinesis data stream. So within these producers can be the KPL, Kinesis agent, and so on. Maybe we want to analyze the data in real time, and so for this we can use Amazon Kinesis Data Analytics. From this, we can have Lambda to do some transformations. We can send the output data into Kinesis data streams as well. And we can also have Kinesis Data Firehose read from the output of Kinesis Data Analytics. This is what we just saw. Then, in terms of analyzing the data, we have two options. We can use Amazon EC2 to read from your Kinesis data stream, and this is very helpful in case you want to have your own custom code to read from it. Or we can use Kinesis Data Firehose to send the data, for example, into Amazon S3 or Amazon Redshift, or to send the data into Amazon Elasticsearch Service. Next, it is possible for us to also have a producer that produce data directly into Kinesis Data Firehose. So the KPL and the Kinesis agent both have the capability to produce directly into Kinesis Data Firehose, and then the data will be sent into Amazon S3. So this gives us a bunch of different options for our real-time layer, as we can see, and also Kinesis Data Analytics, in this example, can read from Kinesis Data Firehose. So I think I've represented all the possible combinations we can have when we have Kinesis, but the idea here is that you need to know which works with what and what is the purpose of using Kinesis data streams, Kinesis Data Firehose, and Kinesis Data Analytics, as well as the costing structure. Another architectural discussion we may have is we have different things to do streaming in AWS. Which one is going to be the more cost effective? So let's say, for example, that you plan on receiving 3,000 messages of 1 kilobyte per second. So this is all your data going to be sent to your architecture. So option number one is to use Kinesis data streams with a Lambda function. And option number two is going to be using a DynamoDB table with a DynamoDB streams and a Lambda function. So ask yourself, what is going to be the most efficient and what is going to be the most cost effective, and what trade-offs are we going to have between these two architectures? Because they both work. Well, for Kinesis, I did some computations for you. So we have 3 shards because we need 3,000 messages of 1 kilobyte. So 3 shards are going to be 3 megabytes per second. And the cost of 3 shards per hour is 3 times 0.015. This is based on some numbers I found on the AWS website. And this gives you about $32 per month of cost. Then to send the data into Lambda, this is very easy. We can just use an event mapper. And if we wanted to send the data for long-term storage, we would need to use something like Kinesis Data Firehose, output it into S3, and we would get long-term storage there. Because Kinesis data streams will have 24 hours to 1 year of data retention, but after that, the data will be lost. So this is a good combo to use KDF to persist the data into S3 very cheaply for long-term storage. Next, when we look at DynamoDB and DynamoDB streams, we need to have 3,000 writes of 1 kilobyte per second. So if you remember, that is 3,000 WCU, write capacity unit, and that gives you 3 megabytes per second. Now, if you do a computation of how much that costs you, this costs you about 1,450 US dollars per month just for that DynamoDB table. So the good thing is that, yes, we do get storage in DynamoDB, so the data can be stored long-term there, but the streaming aspect of things is extremely expensive. So there's a factor 50 of cost between Kinesis and DynamoDB plus DynamoDB streams. So this is something you have to realize as a solution architect. It's not because something works that it's going to be a great solution. And so in this example, both solutions work for streaming, but Kinesis is obviously going to be a much cheaper and probably better choice for what you're trying to do. Okay, so now let's look at all the technologies we've seen so far for data exchange, and we can understand what are the different aspects based on data, retention, ordering, scalability, the possible readers, and the latency. So Kinesis data streams is immutable data, so once it's inserted, we cannot change it, and the retention is up to 1 year. We can export to S3 using Kinesis Data Firehose. The ordering is going to be per shard, and we have to provision the shards in advance. And the readers for the shards can be EC2 instances, Lambda function, Kinesis Data Firehose, Kinesis Data Analytics, and KCL, Kinesis Client Library, that has a checkpointing feature. In terms of latency, if we're using Kinesis data streams, then we have about 200 millisecond latency. And if we're using Kinesis Data Firehose, it's not latency, it's near real time. So it's about going to be 1 minute minimum to flush that buffer size in that buffer into Amazon S3, for example. Next, let's look at SQS. So SQS, the data is also immutable. Once it's inserted, it cannot be removed. And the data retention in SQS is going to be between 1 to 14 days. There is no ordering for SQS standard, and the scalability is virtually unlimited. There's a soft limit, but you can always increase it. The readers of SQS is going to be EC2 or Lambda functions. And the latency in this case is going to be quite low, between 10 to 100 milliseconds. Then we have SQS FIFO, which is very similar to SQS, but the data is still immutable. We still have the same retention, but now there's an ordering we can have thanks to FIFO, which means first in, first out. And so we get ordering per group ID. Now, because we have this ordering constraint, the scalability is going to be different. So we have about 300 messages per second, or 3,000 if we're using batching by batching 10 messages at a time. The readers can also be EC2 and Lambda function, and the latency will be quite low, between 10 to 100 milliseconds. Then we have SNS, which is also going to be immutable data. There's no data retention whatsoever, no ordering. This is going to be also something that scales really well, so there's a soft limit, but you can always increase it. And in terms of what can consume from SNS, these are called subscribers. So it can be an HTTP subscriber, a Lambda function, an email, or SQS queue if we're using fan-out patterns, this kind of stuff. And the latency is going to be quite low, between 10 to 100 milliseconds. DynamoDB now is going to be having mutable data. So once we insert data into DynamoDB, we can override it. The retention of the data can be infinite, or we can implement a time to live on our rows. There's no ordering in DynamoDB. For scalability, we have to use either some WCU and RCU to create and provision our database and maybe have auto-scaling on top of it, or we can use on-demand scaling if we don't know our usage pattern in advance and we have something very spiky, very unpredictable, or very, very, very low. Finally, in terms of what can read from a DynamoDB, well, you have the SDK, but you cannot read a stream using the SDK. You need to create first a DynamoDB stream, and then that DynamoDB stream can be read from a Lambda function or an EC2 instance, for example. The latency is also quite low, between 10 to 100 milliseconds. And finally, S3. Yes, S3 is a way to stream data if you wanted to, if you're a bit twisted. So you can insert data in S3 and replace it, so there is some mutable aspects, but we've seen that there is S3 object locks or versioning that can help against that. The retention is going to be infinite, but we can set up lifecycle policies to transition between different tiers, and we can also have a lifecycle policy to delete data. There's no ordering in S3. For scalability, we get about 3,500 puts per second and 5,500 gets per second per prefix, and the storage itself is infinite. And then the readers of S3 can be the SDK to get a specific object, or we can use S3 events to get notified whenever an object is inserted into S3. In terms of latency, it is quite low, so between 10 to 100 milliseconds. So that's it. Hopefully that was helpful from an architectural perspective. Hopefully it's very clear what are the differences between all these technologies, and you will be able to answer the questions based on them at the exam. All right, that's it. I will see you in the next lecture.